In Chapter 3, we will talk about derivatives, and in Section 3.1, we will define the derivative. So recap from Chapter 2, a tangent line to a curve is a line that just touches a curve at a given point. So it hits the curve only at one point, and whatever point we're looking at. So the slope of the tangent line represents the instantaneous rate of change. So when you have a tangent line to a point at a curve, and we calculate the slope of that tangent line, that tells us the instantaneous rate of change. In other words, the rate of change at that specific point. The derivative is basically the slope of the tangent line at x. In Chapter 2, we learned how to find the derivative using a couple of different methods. One was an approximation where we took this point and then we found another point and we found the slope between those 2 points. We approximated. We also took intervals that came closer and closer to x, and we found the slope of the tangent line that way. But in Chapter 3, we're going to use an alternate method to find the slope of a tangent line. So the x-axis represents the time, and y-axis represents the distance traveled during this trip. So we have a trip here, and this person is traveling, it looks like 380 miles, and it takes them about 5.5 hours to do it. Okay, so the x-axis represents the time, and the y-axis represents the distance. Remember that the slope of the tangent line at any given point, it represents the speed of the car, because if the y-axis is miles and the x-axis is time, so in hours, miles per hour, this represents the speed of a car, right? So what the slope of a tangent line at any given point does is, like, for example, if this is 2.25 hours, this slope of the tangent line tells us the speed of the car at 2.25 hours. Whereas algebra can only tell us the average speed of the entire trip. So calculus gives us more information because it can tell us the speed of a car at any given point in time. So the average speed here, if you're going 380 miles in, let's go with 5 hours. I know it's not exactly 5, but let's just approximate to 5. It's about 76 miles per hour. However, if you want to know the speed, not the average speed, but the speed at this point in time, that's where the slope of the tangent line comes in. Okay, so this problem says use the graph of f of x to estimate the value of f prime of 1. Now, what is f prime? So f prime of x, this is called the derivative at x. Now, what is a derivative? So we looked here. The derivative is just the slope of the tangent line. So f prime of 1 represents the slope of the tangent line at x equals to 1. Okay, so f prime just represents the slope of the tangent line at, in this case, x equals to 1. So how do we find that? Well, we draw a tangent line at x equals 1, and we need 2 different points. So one point is going to be the point 1 comma negative 2. And then another point, so remember we have to choose integer values. I can choose the point 3 comma negative 3. And I can find the slope either by doing rise over run or taking those 2 points. So if I took the point 1 comma negative 2, and my second point is the point 3 comma negative 3, and slope is y2 minus y1 over x2 minus x1, it's going to give me negative 1/2 as my slope. I did it graphically, so I went down 1 across 2, which is going to be a slope of negative 1/2. I could also use my formula. So if I did y2 minus y1, that's negative 3 minus negative 2 over x2 minus x1, and then these become positive, so once again we end up with a negative 1/2. So when you see the notation f prime of x, that is going to be the derivative at x. And what is the derivative? The derivative is simply the slope of the tangent line at any given point. So f prime of 1 is the derivative of the function f at 1, which is the slope of the tangent line when x equals to 1. And that's given by this red line. So we're going to look at the definition of the derivative. And the definition of a derivative is given by something called the difference quotient, which is f of x plus h minus f of x divided by h. You probably saw this in your previous class. And for the derivative, we're going to take the limit as h approaches 0 of the difference quotient, which once again is f of x plus h minus f of x all over h, if the limit exists. And if the limit exists, and we know that, we know that f is differentiable at the point x. And the process of finding the derivative of a function is called differentiation. So, to recap, if you want to find the derivative at a point x, which is given by f prime of x, this is same thing as the derivative, same thing as the slope of the tangent line at that point. This is the derivative, which is also the slope of the tangent line at x. And we can find the derivative given that the limit exists, and that process is called differentiation. Okay, so let's take an example. Given f of x equals to negative 3x squared, we want to find the difference quotient in the first part, and then in the second part, we want to find the derivative. So the difference quotient does not give us the derivative. To get the derivative, which is f prime of x, or the slope of the tangent line at x, it's given by the limit as h approaches 0 of the difference quotient. So let me give you guys a refresher on how to find the difference quotient. So the difference quotient, the numerator has two different parts. We have f of x plus h, and we have f of x. And what I recommend is that you write those down separately. So first, let's figure out what is f of x plus h. Now the x value is just the input. This is simply the input. And the input replaces this x with whatever's in the parentheses. So our function is f of x equals to negative 3x squared. But if you wanted to find f of x plus h, then this input replaces the x on the right side. So if the input is x plus h, instead of negative 3x squared, we have negative 3 times the parentheses x plus h squared, because this x is replaced by whatever's in the parentheses, which is our input. Now, order of operations, we have our parentheses, then we have our exponents, and then we have multiply, divide, and then we have add, subtract. So according to PEMDAS, we have to do the exponent first. So we multiply x plus h squared first. And if you FOIL that, it'll give you negative 3 times the quantity x squared plus 2xh plus h squared. And then if you distribute the negative 3, it gives you negative 3x squared minus 6xh minus 3h squared. And that is just the first part, the f of x plus h. Now we got to figure out what is f of x. Well, f of x is easy. It's just equal to negative 3x squared. In the third part, let's put it all together. So let's take f of x plus h, which is the negative 3x squared minus 6xh minus 3h squared, minus f of x, which is negative 3x squared. Notice we have a double negative, one from the formula, this negative here, and then f of x is also negative itself, and all of that is going to be divided by h. Now let's simplify this a little bit. Let's clean it up. The two negatives turn into a positive. So this gives us a negative 3x squared minus 6xh minus 3h squared plus 3x squared. So the negative 3x squared and 3x squared add to 0. This gives us a negative 6xh minus 3h squared over h. Remember, when you divide two terms by a monomial, which is one term, you can separate those and divide them each individually by h. So I take negative 6xh divided by h and negative 3h squared divided by h. And if I simplify that, it gives me negative 6x minus 3h. So that'll be the first part. The difference quotient, not the derivative, not the limit, just the difference quotient, is going to be negative 6x minus 3h. Now, in the second part, we want to find out what is f prime of x. So f prime of x is going to be the limit of that as h approaches 0. Now, remember that to find a limit, we're just going to use direct substitution. So if h is going to 0, then in this function, I'm going to replace h with 0. Let me write that down a little bit cleaner. So we have the limit as h approaches 0 of the difference quotient, which we know is limit as h approaches 0. I'm sorry, I don't know what's happening with this pen. And the difference quotient, that whole thing simplified, is just negative 6x minus 3h. Right? And remember that the first step to finding a limit is just do direct substitution. If that doesn't work, we can try other stuff, but just do direct substitution. So if I replace the h with a 0, I get a negative 6x. That means the derivative of f of x, which means the slope at any given point, is given by negative 6x. So that's equal to f prime of x. So if I want to find f prime of negative 2, I just plug it in. Let me get rid of this. Okay, if I want to find f prime of negative 2, I know that my derivative is negative 6x. So the slope of the tangent line when x is negative 2 is given by negative 6 times negative 2, which is 12. F prime of 0 is negative 6 times 0, which is 0. F prime of 1 is negative 6 times 1, which is negative 6. All right, so remember to think of questions for class. Okay, let's take another example. If f of x equals to 24x plus 23, then find f prime of 10. Well, before I can find f prime of 10, I first have to find out what is f prime of x. Okay, so to find f prime of x, I'm going to take the limit as h approaches 0 of the difference quotient. So I got to figure out what is my difference quotient. So first, let me find out what is f of x plus h. For f of x plus h, my input is x plus h. So that input replaces the x value. So I have, instead of 24x, I have 24 times x plus h plus 23. If I distribute that, I get 24x plus 24h plus 23. F of x, we were already given that. That's just 24x plus 23. And if I put that all together, then I will get the difference quotient. So the difference quotient is given by f of x plus h, which is this quantity 24x plus 24h plus 23, minus f of x, which is 24x plus 23. When you subtract, make sure you put it in parentheses. That parentheses is extremely important. Otherwise, you might forget to distribute the negative. So make sure that's in parentheses. And then you distribute the negative. So I have 24x plus 24h plus 23 minus 24x minus 23. Now we can clean this up. I can cancel out the 24x's, the 23's, and I'm left with 24h over h, which is just 24. This is a constant function, which means the slope at any point is going to be 24, no matter what the point is. So f prime of 10 will be 24. Now this should make sense because guess what? F of x equals to 24x plus 23. This is a line. In the form mx plus b, the slope is always given by the coefficient of the x. So this line has a slope of 24 at every given point, which is why we have a constant slope. No matter what the point is, the slope will always be equal to 24. Okay, we have another video, but please make sure you think of questions on this video for class.